Today we're going to go over Box Morph and tiling patterns. So this is the kind of stuff that we're going to be looking at. So how do you actually generate a box on a surface or some kind of datum plane, and then how do you map geometry within it? And then the more advanced version of this is going to be how do I map a more intriguing or compelling sort of algorithm within that particular pattern. So let's jump right into it real fast and start to actually look at the tools that we're going to need. And so the first thing I'm going to introduce you to are the two main tools, and then I'm going to describe how to work backwards from them after we've established them. Actually, there might be three main tools. Anyway, what we want is go under Surface and Primitive. And the first thing that I want to mention to you is this one right here. It's called Bounding Box. So the way Bounding Box reads is it says it solves oriented geometry bounding boxes. That probably doesn't mean much to you right now until I pretty much tell you how it works. So it's going to ask for content, and content is just labeled as geometry, because really you can morph a bunch of different types of geometries, whether they're curves or surfaces or things like that. And then a plane. Plane you typically don't have to worry about unless you're doing more controlled applications in terms of geometry orientation. Don't worry about it yet. What you do need to know is the actual geometry input. So let's start off with something relatively simple and also manually generated. So we're going to create something in Rhino in order to use that for our box morphs. So just like one of the simple exercises that you saw up here, like this one and like that one, those are spheres. So go ahead and create a sphere in Rhino, and it doesn't really matter where it is or how big it is. Just kind of drop one on the side. You could put it at the origin if you'd like, but so I'm going to go here and I'll create a sphere here and I'll just drop it kind of close to the origin like that. And then go into your params and reference that sphere in. So go to param, and because it's a sphere you can't use a surface, so you have to use brep. Go ahead and set that brep to the sphere and then plug that into Box Morph. And what you're going to see is that that geometry gets bounded by your Box Morph. Or I'm sorry, not Box Morph, by your bounding box. I'm jumping ahead of myself. So again, that's under Surface and Primitive. So I think you guys are all able to keep up with me on that one. So I'm going to keep pushing forward into the next part. Under Transform, the next two principles that we're going to need here, the new principal tools, are going to be Box Morph and Surface Box. So these two kind of go hand in hand as long as you're using this kind of mapping technique, right? So basically, let's drop in Surface Box, and what it says is it creates a twisted box on a surface patch. So it's asking for a surface and then a surface domain, right? So notice how this has the square version of a domain, so that means you're basically using divide domain squared. And then it has the height of the surface box, which is kind of like using offset surface. It just kind of makes another extension on that surface in the direction of the surface normal. The other tool that we're going to need is Box Morph. And that's also under Morph, and it's this one right here called Box Morph. And its description says it morphs an object into a twisted box. And so it asks for a base geometry, and then it asks for a reference box. That's very important to kind of note here. It asks for a reference box, and then it asks for a target box. And the cool thing about this surface box is it creates a box. This is a box format of geometry. And then it's asking for a target box. And then this one is creating a box around a particular geometry. So what do you think we're going to do? We're morphing one box into the other box's location, orientation, and configuration. So the reference box is going to be this one right here. So it's the bounding box around the geometry we're going to morph. And then the target box is going to be the surface box that we map onto a surface. That would be here. So the part that we're missing in all of this is going to be the surface itself. So I'm going to pause real fast and make sure that you're all caught up to this point properly before I proceed into generating the actual surface. Are there any questions? Not yet. Okay. All right, let's jump right back into it then. So let's push forward with the actual surface. I mentioned that the surface box kind of acts like an offset. And so really we just have to give it a surface to operate on. So I'm going to do something pretty generic, but I'm going to do it warped so that you can really see the difference here. So I'm going to go in my right side view. It doesn't really matter how you guys make this surface right now. Just make something that's kind of, you know, crazy, but not so crazy that it has like an angle like this. Like that's going to be really difficult to see what happens if you do that. So make it a softer curve sort of edge, and don't go, you know, super crazy on the changes here. So I'm going to do something like that and loft the two of them together. Cool. That'll work for me. So with this, because it's asking for a surface, we should be able to reference it in as a surface. So I'll go to param and surface and set that surface that I just created. So if you guys happen to use an extrusion workflow to create this surface, then you're going to have to first reference it in as a brep. Then you're going to have to deconstruct brep in order to isolate the surface of it. Does that make sense? I doubt any of you guys used I doubt any of you guys used extrude to actually create this, but if you do that, then you're going to have to reference it in as a brep and then deconstruct it to get a surface. So I'll turn this layer off. Okay, so this is the surface. I plug it in here, and then I have to define a couple of things. I need a surface domain, and I need the height of the box. So the height is really simple. I can just make a slider from 0 to... I'm going to make this from 0 to 25. I don't know how big you guys made your model, but mine's a little over 50 feet here, so I just want some pretty good flexibility. And then the last part is the domain. Okay, so the domain itself is going to basically just be a subdivide domain of the original surface. And that's going to be under math and domain and divide domain squared. And I'll plug this in here. And think of it like this. When you're using Surface Box takes the place of isotrim, essentially. You could put isotrim in there for if you're doing, you know, panelization exercises and stuff like that as well, but Surface Box will simplify that process for you. So here we go. I'm going to go and do subdivisions from 0 to 10. And then plug that into D. And as you slide your slider out, you'll be able to see the modification here for the Surface Box. Mine's going backwards. If you wanted it to go forward, you could change it to a negative slider or something like that, or reverse your surface. That's an option too. Actually, let me do that real fast because I don't do that enough with you. So let me flip this surface to make sure that it's proper here. So I'll flip surface and then plug that in instead. Look at that, it still went in the same direction. That doesn't make sense. Alright. That was odd. Alright, I'm going to use a negative then. So I'm going to go negative 25 to 25. Alright, there we go. So you can see that what's happening here is that these boxes, these rows and columns are actually morphing and twisting along with the surface itself as it gets thicker. So this is kind of an important place to pay attention to that, because your surface, the surfaces that it creates, like our triangulation exercise, they're warped surfaces. So they're not flat planes. Just be aware that it's not a shortcut to get a flat plane. Anyway, so stepping back to this now, the last thing that we have to do is to implement the geometry into the box morph. And so that geometry here is going to be this brep that I referenced into box morph down there. That is what's going to get mapped. So I'll plug brep into G. And there you go. Let me turn some of the old stuff off. What questions do you have? What? Need help? Okay. I'll come around then.